So let's start with a very basic question. So why tries, right? Before you start studying anything, the why thing needs to be clear, that why we are gonna do it, right? So let's take a scenario that I give you a few words, or let's just say we are gonna implement a dictionary, right? So the basic concept is that I'm gonna give you a few words. So this would be a set of words, right? I'll ask you to store these. So you can store them. So for now, it's a black box scenario for me. I don't know what is happening under the hood. And then I'll ask you that whether this word is present or not. Word is present or not, right? So these are the two scenarios, let's say. Now, in order to implement this, there could be multiple ways. One of the ways is that you can say that, okay, I'm going to store them maybe in a hash map, right? Technically, taking the average case, the complexity would be order of one. That's good enough, right? Order of one, or you can say the order of length of the string, right? So that's good enough. So why do we need tries over here? Now, if you have studied tries before, you would definitely know that one of the most primitive use cases of tries is to implement dictionaries, or some sort of a particular type of dictionary wherein some more operations can be performed. Let's say now these were the two kind of operations. These were operation 1 and this was operation 2, right? Now I say that you need to perform another kind of operation, operation 3. Now this is a bit interesting operation. So I'll say that you need to tell me whether in your entire dictionary there is a string which has a prefix, let's say GLA, right? I ask you this, that do you have a string which is having a prefix GLA or not? This is the question I have, right? How are you gonna do it? Now you'll say that there could be various ways of doing it. We can actually search in the entire dictionary. So we can pick every word from the dictionary and check against it. So that would be order of n, where n is the number of strings. This is a pretty bad algorithm, and we definitely don't want to use it, right? The other thing you can come up with is that if we don't want to sacrifice our time complexity, we can maybe sacrifice the space complexity. So you can say that whenever I'm storing the words in the string, I'll keep storing the prefixes as well. For example, if glass is the word, right? So you'll store all the prefixes for it. So you'll store a G, then a GL, then a GLA, then a GLAS, and then finally a GLASS, right? So you'll store all of these in the dictionary. Let's call it a prefix dictionary, right? And then you can simply search in the prefix dictionary itself whether GLA exists or not. If it does, then yes, there is a string with the prefix GLA, else there isn't. Now this is also fine. It would be order of one, you can say, or order of length of string, you can say. The problem is that the space complexity for it would be too much. So the space complexity for it would actually be order of n into m square, wherein m is the size of the string, right? We don't even want to do this. Now what's the alternative for this? So if I want that the space complexity should also be order of n into m, where n is the number of strings, and m is the size of each strings, right? So how can you do this? This is the problem we are dealing with, right? So what I can say is that we can use a try. Now what is a try? Up till this point, is everything clear? Any doubts so far? Any doubts so far? All right. Yeah, if everything's fine, so let's continue further. So I'm gonna say we are gonna stand at a node, right? We're gonna stand at a node, and let's say this is the head, right? Now I want you to think of it as a graph itself, right? But in the graph we have nodes and edges, right? So we have a node, we have the edge, so on and so forth. But over here, I want you to configure one thing, that the values would actually be stored, or the information is actually stored in the edges itself. So over here, I can say that these are the edges, right? And these are the nodes, right? Okay. So now what you can see is that if we are having a, we are gonna go to this node. If we are having a B, we are gonna go to this node. If we are having a C, we are gonna go to this node. If D or if E, let's draw it again so as to make it more simple. So this is the head node, right? I'm gonna say if you're having a, let's go to this node. If you're having a B, C, D, E, G. Now the point over here is that these nodes actually are not containing the values A, B, C, and D, but actually these edges contain the values a, b, c, d, e, so on to z, right? So d, e, f, so on to z, right? And what do this signify? So this is saying that if I'm having a word a, or if I'm having the first character as a, then I can go to this node, right? So let's say the first character I was having was actually G, because the example we were searching for was glass, right? So I'll say that let's go to the node which was having the first character as G. So I'll go to this node, right? I'll go to this node. Now I'll say what's the next character I need. So he'll say that the next character you need is L. So I'll check that whether this node is having another edge out of it, right? That is having the value L. So I'll search for it. Now there could be two cases. Either there would be no edge having the value L, or there would be some edge, right? In case there's no edge having the value L, then I can say that there's no word in the entire string which is having G and L as the prefix, right? Or there's no string in the entire dictionary which is having G and L as the prefix. In that case, I can simply return a no, right? If that's not the case, then I can say that there would be some string definitely which is having G and L as the prefix, right? So I'll go to the L node. Now this is the L node. After that, what do I need? So I need a. So it would be also having some edges out of it, and either all these edges, or either these edges would be pointing to some other nodes, or they would be pointing to null itself. So let's say a was pointing to some node, b is pointing to some null, so on and so forth, right? So we check. Now we have a L, and what's the next character we need? We need a, right? So we're going to go to a, and we're going to ask over here that is there any node that is having the next character as S or not, because the next character we are going to search for is S, and so on and so forth. We can proceed, but right now we only need information about GLA, right? So if we are able to reach this particular node, right, in that case we can say that okay, GLA at least was available to us, and we can return, right? So we can return in that case. Cool. And we'll return the values true, 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 and the head will eventually return true to us. I hope this makes sense. Any doubts on this? Okay, what I was saying is yes. Okay, all good, bro. I'm a bit nervous now. IGM is kind of here. MT, why are you here? Just a bit curious to know. I don't think he'll respond, but anyway, cool. Okay, so that was the entire concept. Now the other thing is that you might ask. Now let's say I ask you that is there a word GLA in the entire string, in the entire dictionary or not? Now you'd say that using the same logic, we'll reach this particular node and then we'll return a yes, right? But this becomes wrong now, because GLA is not a word. It's just a prefix that was present in the entire dictionary, but not a word per se, right? So how do we improve this? How do we configure so that GLA doesn't comes up as a word or not? Now for this, we can store some information on the nodes too. So let's say on each node that is actually an ending node, we store some value. Let's call this is end, right? So is end would denote whether the word is ending at this particular node or not. So in case of glass, so let's just draw the structure of glass below so that we don't confuse it with the earlier structure. So let's say this was G, this was then L, right? This was then A, and then we have a S, and then we have a S again, right? So this is the final node. So over here in this node, wherein all of it is ending, we'll store the value is end equal to true, right? And for all the other nodes in the middle path, the values would be false. I'm considering that there's only one word in the entire dictionary, that is glass. So for all the other nodes, this value of is end is false, right? Now whenever I'll do the computation, so there would be two operations. The second operation was finding if the word X exists, right? And the third operation was finding if the prefix, if the word maybe like X again, right? If the word X exists as a prefix of some string in the dictionary, right? This is what we want to do. Now in order to do this, what I'm saying is, let's just wait for a second. Okay, cool. Now in order to do this, what I'm saying is that whenever I'm checking if the entire word is present in a dictionary or not, in that case, I'll have to look for the node, or my ending node necessarily need to have this is and equal to true. Only then I can say that the at this particular node a word was ending. If that's not the case, and if I'm checking for this third kind of operation wherein it should only be a prefix, it's not required that the ending node should be false, right? It can be true or false. It either way denotes that at least there was some prefix having this particular value. Cool. So I hope this makes sense. Okay. Any doubts so far? If not, I'm gonna continue. So just wanted to know if everything's fine. No, easy peasy. Yeah, it's actually easy. That's what I was saying, right? Most of the time, the questions most of these companies are gonna ask you are not tough. They are actually easy. It's just that they want to check your implementation skills, or sometimes the way you are gonna tackle the problem. Prefix could be the whole world. No, yes, it could be, but it doesn't matter, right? Now, if I ask that if glass is a prefix or not, you can just return it's true, right? Like over here, you need not check. So over here, you need not check. If I'm asking you for a prefix, let's just define it again. So storing is done, right? And when we'll see the code, you'll be able to see that how we're going to store it. The second operation was checking if the word is present, right? And the third operation was checking if the prefix x is present, right? Is present. Okay. Now storing was a different thing altogether. Let's not talk about that. But now if a word is present, in that case, I have to check that the ending node, right? This should be true, right? However, if I'm only talking about the prefix, then the node should exist, right? So if I'm talking about GLA, then the node which is like just after a, that should exist. I'm not even concerned about if it's the end node or if it's a middle node. Everything's fine for me. Yeah, that makes sense to you? Okay, so it's a implementation based problem. It says that a trie or a prefix tree is a tree data structure used to efficiently blah blah blah. I'm not going to go through the problem statement, but they basically want us to implement a trie, right? So let's just copy paste the code in Visual Studio Code. It looks better over here, not over here, but let's just copy it over here. Cool. And, okay, my bad. Let's copy it here. Okay, cool. So now let's try to understand how the code works in case of a try. Now I would actually
Kindly zoom it.
sure. I'll zoom it a bit. Is it fine now, guys? Is this fine now?
Yeah.
Okay, cool. So now comes the part of how to implement a try. Now I actually recommend whenever you are coding something up, or if you're gonna save it as a snippet, it's kind of recommended that you should be using class-based data structures, or basically the implementation should be in form of a class, so that you can easily utilize the methods. Okay, so in that we have some functions. So we have the basic constructor, right? We have the insert function, we have the search function, and that then we have a starts with function. So basically this is the prefix. If prefix of some string is present, right? Okay, and this is if some string is present, and this is about storing the string, right? Storing the string. Cool. Now let's go by them one by one. So let's understand what's happening in case of insert. So firstly say that okay, start it, and then it's saying that node is equal to this. Now what does this mean? So this basically means that whenever you're gonna call the function insert, right? So you're gonna say that okay, so my try or whatever name you have given to the object dot insert, right? So you're gonna say insert word. Now as soon as you do it, this basically points to the object itself, right? So he's gonna say that I need a pointer to the current object itself, right? I need that pointer, and now let's start traversing it. So he'll say for all the characters in this word, firstly I'm using a zero base indexing, and the word and in the ASCII the values can be from 0 to 255, right, in the ASCII system. But since I'm just going to store the lowercase characters, so let's just subtract the value 97 from it, or the value of small a from it, so that the remaining characters are in the range 0 to 20, 25, right? So I'm going to do that. Then I'm going to check if the link or the edge exists for this character. So this is this particular thing right over here. Okay, take a second. Okay, so this is this particular thing right over here. So I'm going to check if a exists, if b exists, or if c exists, so on and so forth, right? So this is the edge over there. The name given to the edge is actually link. Both actually mean the same thing. So yeah, if the link exists, then it's fine. But if the link is set to null, in that case I'll have to that case I have to initialize it, right? Because I'm trying to store a character. So it would be of the scenario, let's say we already had one of the words in the dictionary. Maybe we had the word 8. Okay, not like this, but yeah, this was the head pointer. Then we had a, then we had a t, right? And then we have a e. Right now I want you to store ape. So you'll say, you'll go to a. This node was already existing, but at this particular node you'll say that okay, p is not existing. So what do I do? So I insert a new edge to a pointer, right? So this step is being formulated over here. So it's saying if it doesn't exist, let's just create a new node, right? So it's saying this link would now point to a new pointer, or a new, you can say, a try class, try object, right? So it's gonna point to a new try object. And now you're gonna say that you're gonna move your pointer from the current pointer to the new node. So basically currently you are having your pointer right over here, right? So in the first iteration you move your pointer over here. In the second iteration you'll move your pointer over here. So that is being done by this particular line, right? At the end you would have stored all the characters, and eventually you'll be standing at the last location. So for example, if you have already stored all the characters of ape, right, ape, so you are standing over here, right? And now since you stored a character, or stored a word actually, so you need to mark it as true, right? So is end needs to be marked true. So that's what I'm gonna do over here. Cool. Any doubts? Sounds good. Okay, so the next is the search function. The search function also is somewhat identical. Now in tries, most of the times the functions would somewhat be identical, unless and until you are doing some complex operations. So this code kind of seems identical to this, right? Now let's try to understand what it's doing. So in the search, again, we are starting with the root node itself. So we are just saying that I want to point myself to the root node. After that, in the similar operation, I'm going for all the characters, then subtracting the value of a so as to get the zero base indexing. And after that, the difference is, in case it was null over here, so if a link did not exist, I was actually populating that link. But in this case, if the link does not exist, right, that means there's no word of this, there's no word like word. So let's just make it WRD so that I don't confuse it. So there's no word WRD in the entire string. If that's the case, I'll return false, right? Because I have to tell them that there's no such word what you will like looking for. Else I'll have to update my pointer to the next pointer. You can do it like this. Okay. After that, let's say your entire string is traversed, right? Now you're standing at a particular point. Now since it is the search function, so since I already told you, if it's the search function, the last node should have the value of isn't as isn't as true. So we are gonna say whatever the value of last node is for is in. That's the final answer. Because if we are standing at a node but it's not the end node, in that case the answer does not there's no word of WRD, right? So we are going to return that value. Now if you look at this function, this is exactly identical, right? So that entire implementation would be the same. The only difference is at the very end we don't care if we are standing at the end node of end node or not. In either case we are standing at some node which is a prefix of some word, right? So we can either we return true for this. So we're going to return a true. Over here we were returning node is end. So yeah, that's pretty much it. That's how you implement a try. Let's try to run this. I hope I didn't change something and broke something. Seems good to me. Let's submit this. Yep, I think it worked. Yep, it worked. Cool. So yeah, that's pretty much about tries. Do you guys have any questions that I could answer? I could help with? All clear, guys? Okay, one more thing. So whenever you are implementing such things, I won't advise you to code it up from scratch. For example, in my code base, I do have this snippet called TRIE. Now whenever I'll click on it, this entire code base would populate for me. Yes, I'll have to make some changes. For example, it could be the case that over here I'm having 10 variables, so it could be the case I need maybe like 26 variables in case I'm storing words, maybe like 25 255 characters in case I'm storing all the sky values. These things can change, right? So over here also 255. For majority part of it would remain same. So structure node is done. After that, I'll definitely be having a root. You can get rid of it. You can either do it like this, or you can say it to be this. Either way, it'll work the same, right? So yeah, rest things would remain the same. There would definitely would be a add operation, and then there would be a query operator, which you can formulate. Now come the point how we can implement it at other places. So one of the prime implementation for tries is getting dictionaries. So that is one thing we already talked. So we already talked about dictionaries, right? The next is XOR operations, right? What do I mean by XOR operations? Now, standing at a particular point, you want to know if there's an element which would produce the maximum XOR with this particular number. Now, this is another operation that I expect you guys to learn and code it up. But anyway, in a few days, I'll plan a next session, and in that we can discuss about this. So I hope that would work. I'm gonna close the recording now.